Hello, and today I'm going to show you what implicit differentiation, or how to solve problems using implicit differentiation. Now, the majority of functions in Calc 1 are usually dx, but sometimes they're in terms of y, dy dx, which means it's to be solved implicitly. Now, I'll do a couple examples to show you what you do when you have both x and y in an equation when you want to take the derivative of it. Alright, so for the first problem, we're going to solve x squared plus 4xy plus y squared equals 13. Now, just immediately looking at this, we need to use the multiplication rule and the power rule. We're going to be using the power rule here and the multiplication rule here and the power rule here. So make sure you just, well, you can check out my other video on the multiplication rule if you need to brush up on that. But alright, so we're going to continue. So you just on anything with x's, or right here, you just find the normal derivative. So f prime of x. Actually, let's not put that. It's going to equal 2x. Sorry. It's going to be equal to 2x plus, so we have the multiplication rule here. It's going to be second time, actually I usually leave space because I like to have the x's first. Helps me think. Alright, so I do second times derivative of the first, so this is going to be 4y plus first 4x times derivative of the second. Now, when we take the derivative of a y, we're going to actually write, so this is going to be 4x dy all over dx. Whenever you take the derivative of the y, you have to write dy over dx. This is true for the y here too. So we're going to do plus 2y dy dx. This is going to equal 0 because this just disappears. Alright, so now that we have the dy's here, and things here, we're actually going to bring this over. We're going to bring the non-dy's over. So it's going to be 4, let's see, is it still on screen? Alright, 4, how do I write this? I'll write it, I usually like to keep the dy dx's on the left. So we're going to have 4x dy dx plus 2y dy dx equal to negative 2x minus 4y. Alright, so now from here, you can actually factor out the dy dx. So we'll be left with dy dx times 4x plus 2y equal to negative 2x, fix that, negative 2x minus 4y. So now that we've factored it out, you can now, since this is multiplying this entire thing, you can actually divide this over. So this is actually going to give us the answer. Dy dx is going to be equal to negative 2x minus 4y all over 4x plus 2y. And this is the answer to our problem. Oops, went off screen. So this is the answer to the problem. So I'm going to show you another example. I should have showed you a more simplistic example. It's kind of my mistake. First, I'll do that one next. So let me just erase the board. Here, give some extra space. Alright, so we're going to do, this is the one I should have showed you first. X squared plus y squared is equal to 25. So, well, since I already showed you the more complicated example, this one's super easy. Just using the power rule for both of these. So we're going to be left with 2x plus 2y. But wait, since we took the derivative of y, we need to add a dy dx. equals 0. So then we just bring the 2x over, like we did in the other problem. So 2y dy dx is equal to negative 2x. Then we can just divide this 2y, divide 2y, and we are actually left with dy dx is equal to, the 2's up here cancel, left with negative x all over y. And this is the answer to this problem up here. See how I should have showed you that first, because it's a lot easier than, because you didn't have to do the multiplication rule in this one. And it looks like we have time for one more example. This one, let's see, it looks like it has, here, I'll write it out. X squared plus 5x minus 4y squared plus 3y plus 21 equals 0. Sorry, went off a bit, but that's not really relevant. We're just really going to focus on these first 4 things here. Alright, so we're going to have, this is actually going to be equal to 2x plus 5, because you're using the power rule, minus 8y, remember, because when you take the derivative of anything with a y, dy dx plus 3 dy dx, because there's a y here. And then this stuff just cancels up here, because when taking the derivative, it just disappears. So that's equal to, actually the 0 is still there, so it's equal to 0. So now we're going to bring over the 2x and the 5. So this is going to equal to negative 8y dy dx plus 3 dy, I'm going sideways, dx is equal to negative 2x plus negative 2x minus 5. Don't forget, don't mess up like that. Negative 2x minus 5. So now we just have to factor out the dy dx. So if dy dx times negative 8y plus 3 is equal to negative 2x minus 5. So then we just divide this out, like in the other problem. So we're left with dy dx is equal to negative 2x plus 5 minus, I keep writing plus, minus 5. 2x minus 5 all over negative 8y plus 3. And this is the answer. I keep going off screen, sorry. It's the this is the answer to this function up here. This is the, like when you derive implicitly, this is the answer to that equation. So just to recap, when you're solving implicitly, you're going to want to add a dy dx whenever you take the derivative of anything with a y in it. That goes for the multiplication rule. Like when you're in the middle of multiplication rule, when it's second times derivative of the first plus first times derivative of the second, when the y comes up, that's when you add the dy dx to that equation. So then you just get the dy dx. You bring the non-dy dx variables to the one side. Then you factor out the dy dx. Then you divide by whatever that was factored out over to the other side, and then you're left with the answer. So that is implicit differentiation in a nutshell. It could definitely get more complicated, but I just wanted to show some simple problems. Yeah, that's implicit differentiation.